All right, this is video 3.3 for geometry. Today we are going to be proving how, or finding ways that you can prove that two lines are parallel. So for all of the postulates and theorems that we've done previously in this chapter about corresponding angles and alternate interior, alternate exterior, same side interior, all of those say that if you have two lines that are parallel, then your transverse cuts it, then those angles are going to be congruent. So the converse of those now most of the time you can't say that a converse is necessarily true if your condition is true, but for each of these, and we will prove them to be true, is that if you have two coplanar lines, if you just have two lines that are cut by a transversal, if the corresponding angles are congruent, then the two lines are parallel. So then you're taking what we did in the last section and making it to show that the opposite is true as well. As if you've got two corresponding angles that are congruent, then the two lines that are being cut have to be parallel. So in this case, then if angle 1 and angle 2 are congruent and they are corresponding angles, then L has to be parallel to M. Now remember, the way we would say that two lines are parallel is we'd say L is parallel to M. So let's use that one. We're going to use the picture here and the converse of the corresponding angles postulate to show that L is parallel to M. Okay, so if we know that angle 1 is congruent to angle 5, these two are corresponding angles. And so if corresponding angles, using the angles postulate, we can say that L is parallel to M. So let's try it. If we know that the measure of angle 4 and the measure of angle 8, and we know that x is equal to 65. So those are corresponding angles, which means they should be congruent. So let's check that out and make sure they're congruent. So we're not told they're congruent like we did in the first one. We have to figure out if they're congruent. So I'm going to place my x into each of these and see if they are congruent. So I'm going to do 2 times 65 plus 10 is 140, and then I'm going to do 3 times 65 minus 55 is 140. So then from there we can say that angle 4 is congruent to angle 8 because the measure of angle 4 is equal to the measure of angle 8. So they're congruent. That would be by definition of congruent angles. And using the we can say that L is parallel to M using the converse of corresponding angles postulate. So the other ones, hopefully you have an idea of what they are just because we said we're going to be using the converse of all these. So a parallel postulate says that if you have a point P not on line L, so let's say that we've got line L and we've got point P right here, there's exactly one line parallel to L that goes through P. So there's this one line right here, and in the book it shows you how you would construct them. I'm not going to make you construct them. Just know that there's one line that would be parallel to L that's going to contain P. That's the parallel postulate. Converse of alternate interior says that if you've got two coplanar lines that are cut by a transverse so that your alternate interior, these two right here, are congruent, then your two lines have to be parallel. Alternate exterior, if you've got two lines that are cut by a transverse and your alternate exterior angles are congruent, then your lines are parallel. And then same side interior, if you have two lines that are cut by a transverse, the same side interior, our angles are supplementary. So if we have our two lines, and I said that this was 100 degrees and this was 80 degrees, then we know that they are supplementary. That means that my two lines have to be parallel. All right, so let's try this one. We're going to use the given information and the theorems we've learned to show that R is parallel to S. And I don't think I labeled which one was R and which one's S, so let me go back and do that. This one is R, and this one is S. So if we know that angle 2 is congruent to angle 6, those are alternating interior angles. If they are congruent, then R has to be parallel to S. If we know that the measure of angle 6 and the measure of angle 7 are these, and we know what X is, we can put those in place there. And these are same side interior, so that means that measure of angle 6 plus the measure of angle 7 has to equal 180 in order to prove that R and S are parallel. So I'm going to place my 10 in place of my X, so that would be 60 plus 18, which is 78. And then 9 times 10 is 90, plus 12 is 102. So does 78 plus 102 equal 180? It does. So we would say that the measure of angle 7 plus the measure of angle 6 equals 180, which means that angle 7 and angle 6 are supplementary by the definition of supplementary angles. And then by the converse of same side interior, converse of same side interior angles, we would say that R is parallel to S. All right, so this is what the proof would look like. We are going to prove that R is parallel to P using that L and M are parallel and that 1 is congruent to 3. So I'm going to go through here and I'm going to say that L and M are parallel and that 1 is congruent to 3. All right, so the first thing I'm going to write is my given. So I'm going to say L. Goodness. I'm going to have to write my L in cursive. So L is parallel to M, and that's a given. Since L is parallel to M, then angle 1 and angle 2 have to be congruent. So I'm going to say angle 1 is congruent to angle 2, and that is corresponding sides, or corresponding, not sides, angle, corresponding angle theorem. Okay, so now I'm going to go from looking at it as these two are the parallel lines to looking at it as these two are the parallel lines. Angle 2 and angle 3 are alternating, they are alternating exterior angles. So they're alternating exterior angles, but I can't say that they're congruent yet. However, I can say that angle 1 is congruent to angle 2, and the angle 1 is congruent to angle 3. So if angle 1, let's go ahead and put that in. Angle 1 is congruent to angle 3, and that's a given. Now then I can combine these two, and I can say if angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, I can say that angle 2 is congruent to angle 3. You could call that the transitive property of congruency. Okay. If angle 2 and angle 3 are congruent, that means because they are alternating exterior angles, that R is parallel to P because of the converse of the alternating exterior angles theorem. That'll be it for today. When you come to class tomorrow, we will prove a couple of the others as well as do some practicing of showing that lines are parallel using our converses here. Have a good evening. I'll see you later.